Hi, hello friends. Welcome to Indian Tech Guru for you. Let us continue the part 2 of the video regarding reliability design using dynamic programming. If you have not watched the part 1 video, so first of all, go through the part 1 video. The link is available in the description. Then come back to watch this video. So in the previous video, we have seen how to calculate the upper bound values. Here U represents the upper bound upper bound. Okay, so the given values are how many devices are there, and what is the cost of each device, and what is the reliability of each device. These values will be given, and we have calculated the upper bound values. So these upper bound values represent at maximum how many instances of a particular device we can procure. And in addition to that, we have the maximum cost. Maximum cost is given, so it is given as 105. And in addition to that, we have seen how to calculate r power 1 suffix 1, r power 1 suffix 2. These values represent the reliability of a particular device whenever there are one instance or more than one instance. So r power 1 suffix 1 represents, this one represents the device, that is we are handling with the device 1, and this one represents the instances. So that is r power 1 suffix 1 represents so one instance of the first device reliability. If there is one instance of a particular device D1, then the reliability will be 0.9. If there are two instances, then the reliability will be 0.99. And here you can see that the upper bound for D1 is 2. So we need to calculate up to 2 instances. Similarly, for the second device, we need to calculate up to 3 devices. So that's why R power 2 suffix 1, R power 2 suffix 2, R power 3, R power 2 suffix 3. And then for device 3 also, the upper bound is 3. So we need to calculate R power 3 suffix 1, R power 3 suffix 2, R power 3 suffix 3. So these values. How to calculate these values we have seen in the previous video. And in addition to that, now we need to calculate the cost whenever we are using a single device or more than one device. That is a single instance of a device or more than one instance of a device. So let me calculate C power 1 suffix 1. C power 1 suffix 1 represents that there is a single instance of device 1. Device 1 cost is $30. So C power 1 suffix 1 will be 30. And C power 1 suffix 2 represents two instances. If one instance is 30, then two instances will be 60. Similarly, for second device, C power 2 suffix 1. One instance of second device is 15. And if there are two instances, C power 2 suffix 2, 15 into 2, 30. If there are three instances, 45. Similarly, for device 3, C power 3 suffix 1 equal to device 3 cost is 20. If there are two instances, then the cost is 40. If there are three instances, then the cost is 60. So these are the values we have successfully calculated. So why we are calculating these values is we need to use these values while solving the reliability design problem. To solve the reliability design problem, we need to have an ordered pair R comma C, where R represents the reliability and C represents the cost. And we will be solving this reliability problem using the set method, which is similar to solving the 0 by 1 knapsack problem. So basically here we need an initial set with predefined values s power 0, and the values here will be 1 comma 0, where 1 represents the reliability and C represents the cost. Because there is no device which we have purchased till now, the reliability will be very high and the cost is 0. Now based on the S power 0 value, we need to calculate S power 1 value, S power 2 value, and S power 3 value. So we can calculate S power 1 value, S power 1 value such that S power 1 suffix 1 union S power 1 suffix 2. So the S power 1 value will be S power 1 suffix 1 union S power 1 suffix 2. Now how to calculate S power 1 suffix 1? S power 1 suffix 1. So S power 1 suffix 1 can be calculated using the values of S power 0 as well as the values of R power 1 suffix 1 and C power 1 suffix 1. So we know the values of R power 1 suffix 1 and C power 1 suffix 1. Now we need to multiply the reliability with the reliability of set S power 0, and we need to add the cost of this particular single instance to the cost of S power 0. So that is 0.9 into 1 comma cost is 30, 30 plus 0, that is equal to 0.9 comma 30. So this is the ordered pair we'll get for S power 1 suffix 1. Similarly, we need to calculate S power 1 suffix 2. For calculating S power 1 suffix 2, we need the values of R power 1 suffix 2 and C power 1 suffix 2. So using the S power 0, we can calculate S power 1 suffix 2. The method is same. Multiply the reliability value with the reliability of S power 0 and add the cost with the cost of S power 0. So reliability is 0.99 into 1 comma. Now the cost is 60. 60 plus 0. That is equal to, we'll be getting 0.99 comma 60. So this order pair we are going to get. Now based on the S power 1 suffix 1, S power 1 suffix 2, so we can calculate S power 1 value. So S power 1 will be union of these two sets. That is, we will be getting the ordered pairs 0.9 comma 30 as well as this order pair 0.99 comma 60. So like this we can calculate the S power 1. Now S power 2 can be calculated based on the values of S power 1. Based on the values of S power 1 as well as the reliability and the cost of S power 2 secondary device. Okay. So now S power 2 will be calculated as S power 2 suffix 1 union S power 2 suffix 2 union S power 2 suffix 3. So here we are taking 3 sets, whereas here we have taken only 2 sets. So what's the reason? The reason is here for device D1, the upper bound is 2 only, but for device D2 the upper bound is 3. So we need to consider 3 sets. So how to calculate the values for these 3 sets? So let us start. S power 2 suffix 1 is equal to, so consider R power 2 suffix 1 and C power 2 suffix 1. So multiply with the reliability of S power 1 with reliability of S power 1 and add the cost to the cost of S power 1. Okay. So what is the reliability? 0.8. 0.8 into 0.9 comma cost is 15. 15 plus 30. So repeat the same for all the ordered pairs. Comma 0.8 into 0.99 comma 15 plus 60. That is equal to, so 0.8 into 0.9, 0.72 comma 15 plus 30, 45. This is one order pair comma 0.8 into 0.99, 0.792 comma 15 plus 60, 75. So this is S power 2 suffix 1. Now let me calculate S power 2 suffix 2. So S power 2 suffix 2 is calculated based on the values of R power 2 suffix 2 and C power 2 suffix 2. R power 2 suffix 2 is 0.96. 0.96 into this value 0.9 comma, and C power 2 suffix 2 is 30. 30 plus this value 30 comma 0.96 into this value 0.99 comma this 30 plus this value 30 plus 60. So that is equal to, we'll be getting S2 S power 2 suffix 2 as 0.96 into 0.9, 0.864, 0.864 comma 30 plus 30 60 comma. So here, instead of calculating this value, first calculate the first calculate the 30 plus 60 value. 30 plus 60 is 90. So here we may observe that the cost is $90. The cost is $90 for S power 2 to the base 2, that is S power 2 suffix 2. What does it mean? If we purchase two instances of device 2, two instances of device 2, so the maximum expenditure is 90. So then what will be the remaining cost? So the actual cost given is 105. So 105 minus 90. The remaining dollars will be 15. So however, device 3 cost is $20. So we cannot purchase device 3. But to build a system, as we discussed in the previous video, definitely there must be at least one instance of each device. So that's why, so this particular ordered pair we need not to consider. So let me have some space here. So I have calculated up to S power 2 suffix 2. Now I need to calculate S power 2 suffix 3. Let me calculate S power 2 suffix 3. S power 2 suffix 3. So for calculating S power 2 suffix 3, I need the values of R power 2 suffix 3 and C power 2 suffix 3. 0.992 and this one is 45. 0.992 into 0.9, 0.9 comma. So C power 2 suffix 3 is 45. 45 plus this 30. Second order pair 0.992 into 0.99 comma 45 plus the 60. So that is equal to 0.992 into 0.9, 0.8928 comma 45 plus 30, 75. And before calculating the second order pair, first of all see this cost value 45 plus 60, 105. The maximum cost is 105. Here the cost is 105. That's why we cannot purchase the at least single instance of third device. So discard this particular entry. Okay. So now we have calculated S power 2 suffix 1, S power 2 suffix 2, S power 3 suffix 3. Now we can calculate S power 2. S power 2 is nothing but the union of S power 2 suffix 1, S power 2 suffix 2 and S power 3, S power 2 suffix 3. in which we have discarded some of the entries and we have some of the entries. We need to consider some of the entries. Okay. So now the consolidated S power 2 will be S power 2 is equal to S power 2 suffix 1. So these values 0.72 comma 45 comma 0.792 comma 75 comma and S power 2 suffix 2, this value 0.864 comma 60 comma and this value 0.8928 comma 75. So these are the resultant tuples for S power 2. Now let me calculate S power 3. S power 3 is calculated based on the values of S power 2 as well as R3 suffix 1, R3 suffix 2, R3 suffix 3 and C3 suffix 1, C3 suffix 2, C3 suffix 3. So let me have some space here. I'm deleting the remaining part. So now let us calculate S power 3. So what is the upper bound of S power 3? That is the device 3. The device 3 upper bound is once again 3. So we need to calculate up to S power 3 suffix 3, where power 3 represents the device number and suffix 3 represents the instances, number of instances. Okay. So now let me start solving the S power 3 value. So to solve the S power 3 values, what is the formula? The union of all the remaining sets. That is S power 3 is equal to S power 3 suffix 1 union, S power 3 suffix 2 union, S power 3 suffix 3. So first let me calculate S power 3 suffix 1. So for S power 3 suffix 1, what we need to have? We need to have these tuples, all these tuples, and we need to have R power 3 suffix 1 and C power 3 suffix 1. However, before actually proceeding, let me check whether it is following the dominance rule or not. So here if you see the reliability 0.72 is less than 0.792, 0.792 is less than 0.864 and 0.864 is less than 0.8928. So these are in the ascending order. And if you consider the cost, 45 is less than 75, but 75 is greater than 60. So that's why what does it mean? This particular tuple is following the dominance rule. So the dominance rule we have already discussed in the set method of 0 by 1 knapsack problem. You can watch that particular video. It simply says that if Ri value is less than or equal to Ri plus 1 value and Ci value is greater than or equal to Ci plus 1 value, then we can remove the tuple Ri comma Ci. So now it is following the rule. 0.792 is less than or equal to 0.864 and 75 is greater than or equal to 60. So because it is following the rule, what we need to do? We need to remove Ri comma Ci, this particular tuple. That is, this tuple we need not to consider. What are the remaining tuples? 0.72 comma 45, 0.864 comma 60. Don't be confused, this into is for this particular order pair. So 0.8928 comma 75. Okay, so this is the dominance rule. Based on the dominance rule, we have eliminated one of the ordered pair. Now there are remaining three ordered pairs we need to consider and calculate the S power 3 suffix 1. So now let me calculate S power 3 suffix 1. So for that purpose, I need to consider R power 3 suffix 1 and C power 3 suffix 1. That is 0.5 into 0.72 comma cost is 20, 20 plus 45 comma this one 0.5 into 0.864 comma cost is 20 plus 60 comma 0.8928 into 0.5 comma cost is 20 plus 75. So that is equal to 0.5 into 0.72, 0.36 comma 65 comma 0.5 into 0.864. This is 0.432 comma 20 plus 60 80 comma 0.8928 into 0.5 0.4464 comma 20 plus 75 95. So these are the values for S power 3 suffix 1. Now let me calculate S power 3 suffix 2 values. So for that we need R power 3 suffix 2, C power 3 suffix 2. It is equal to 0.75 into 0.72, this value 0.72 comma what is this C power 3 suffix 2? 40, 40 plus 45 comma 0.75 into 0.864 comma 40 plus 60 comma and here instead of calculating this value, let me calculate the cost value. Cost value is comma 40 plus 40 plus this 75, this 75, 40 plus 75. So 40 plus 75 is 115. Actually the maximum cost is 105. It is exceeding the maximum cost. So why I'm not calculating this product is it is not needed because this particular order pair will be discarded. Okay, so what are the remaining order pairs? 0.75 into 0.72, 0.54 comma 40 plus 45 85 comma 0.75 into 0.864, 0.648 comma 40 plus 60 100. So these are the two ordered pairs we got for S power 3 suffix 2. Similarly, we need to calculate S power 3 suffix 3. So let me have some space for that. I am deleting S power 2 suffix 3, so which has been already calculated. So after calculating S power 3 suffix 3, we can calculate the value of S power 3. So now let me continue. S power 3 suffix 3. S power 3, to calculate S power 3 suffix 3, we need the value of R power 3 suffix 3 as well as C power 3 suffix 3. And we need the values of S power 2. So R power 3 suffix 3 value is 0.875 into this value 0. 72, comma, C power 3 suffix 3 is 60. So 60 plus this value 45. And before calculating the remaining values, first calculate the cost so that we can check whether that particular entry will be deleted or not. So don't calculate the reliability, calculate the cost. Cost is 60 plus 60. 60 plus 60 is 120. 120. So exceeding maximum cost, discard this entry. Similarly, the third tuple is don't calculate reliability, calculate the cost 60 plus 75. 60 plus 75 is 135. So no need to consider, discard this entry also. So only one entry will be there for S power 3 suffix 3. So that entry is 0.875 into 0.72. The value is 0.63, comma 60 plus 45, 105. So this is the only entry left for S power 3 suffix 3. So now we can calculate the S power 3 value by combining all these entries. So let me have some space here to summarize the S power 3 value. Now we don't need this entry because we have already calculated all the values of S power 3. Just we need to perform the union operation so that we'll get the S power 3 value, finalized S power 3 values. So now what are the finalized S power 3 values? Let me write here. S power 3 is equal to S power 3 suffix 1 values. First of all, they are 0.36 comma 65, first order, this one first order pair, and comma 0.432 comma 80, this value, and then 0.4464 comma 95, this tuple, comma, and for S power 3 suffix 2, S power 3 suffix 2, so there are two ordered pairs, 0.54 comma 85 and 0.648 comma 100. And for S power 3 suffix 3, there is one tuple 0.63 comma 105. So let me take this particular ordered pair 0.54 comma 85, and then if you observe here, so 0.648 is greater than 0.63. So that's why we need to write first of all the reliability which is having less value. So that's why I will be taking this particular tuple 0.63 comma 105 comma, and then this tuple 0.648 comma 100. However, if you observe here, it is following the dominance rule. 0.63 is less than 0.648, but 105 is greater than 100. So which ordered pair we need to discard? This particular ordered pair we need to discard. So this ordered pair will not be there in the finalized tuples of S power 3. So how many are left? 1, 2, 3, 4, 5. 5 tuples are left with. Similarly, if you observe here, 0.4464 is greater than is less than 0.54, but 95 is greater than 85. Okay, so 0.4464 is less than 0.54, but 95 is greater than 85. So these two order pairs are also following the dominance rule. So that's why we need to discard this particular entry also. So now how many entries are left with? Only three entries. So this is first one, second one, third one. First entry, second entry, third entry. Like this, we need to calculate S41, S42, and S43 values. Now we have successfully calculated the sets S41, S42, S43. So it is time to determine the solution for reliability design. So I'll be erasing all this data and writing down only the tuples that are available in S41, that are available in S42, that are available in S43, and then we'll solve the problem of reliability design. Okay, now I have summarized all the previous data so that it will be easy for to determine the final number of instances that are needed to build the system with the available cost. So what is the maximum cost available? Maximum cost available is 105. So we need to fulfill this particular cost. So these are the values of S40, S41, S42, S43, and how we got these values. This is the final row, S43. And what is the maximum cost that is available in S43? The ordered pair 0.648, 100. So this is the maximum cost available. So now we need to check this particular tuple from where we have got this particular tuple. We have got this particular tuple from this particular set. So S power 3 suffix 2, this particular set. So what does it mean? Here 3 represents the device, 3 represents the device, and 2 represents the number of instances. So we need to take the third device as the number of instances as 2. Okay, so there must be 2 instances of device 3. So from where from how we got this particular result? Based on the maximum tuple, based on the maximum cost tuple that is available in S power 3, and from where this particular tuple has arrived. So it is arrived from S power 3 suffix 2. So the number of instances here, suffix 2 represents the number of instances. The number of instances must be 2. Now we need to determine from where this particular tuple we have got using the values of S power 2. Using the values of S power 2. Okay. So actually we have got this particular ordered pair from this particular entry in S power 2. In S power 2. Okay. So with this we cannot get how many instances are needed for device 2, but we need to check from where this particular tuple has come in the sets of S power 2. So it came from this particular set, that is S power 2 suffix 2. So what does it mean? Here this 2 represents the device name and this 2 represents the number of instances. It shows that we need to establish 2 instances of device 2. Here you can see 2 instances of device 2. And then we need to check from where this tuple has come. This tuple has come from the first ordered pair of S power 1. And we need to check from where this particular tuple has come within S power 1 suffix 1 and S power 1 suffix 2. So it has come from S power 1 suffix 1. So from here it has come. Here you can see that this one represents the device and this one represents the number of instances. So device D1 must be a single instance. A single instance. So like this, we are going to get the result. The final result is how many devices we need to consider all the devices definitely to make sure that the system is built, and how many instances we need to purchase of each device. So we need to purchase a single instance of device 1 and 2 instances of device 2 and 2 instances of device 3. So let me calculate the cost. If we purchase one instance of device 1, then what is the cost? The cost is $30. 30. plus if I purchase 2 instances of device 2, what is the cost? 15 into 2, that is 30, plus if I purchase 2 instances of device 3, then what will be the cost? 20 into 2, 40. That is 30 plus 30, 60, 60 plus 40, 100. So using $100, I can establish this particular system, and the maximum cost is 105. So the required cost is less than the maximum available cost. Okay. So like this, we have successfully solved the reliability design problem. Hope you understand the logic. So don't forget to watch part one video before watching this particular video. Otherwise, you could not understand the logic. Thanks for watching. That's all for now.